Hello, welcome to Math 2231 online delivery for April 7th, 2020, and this is part 3 of 3 parts in this lecture, and this lecture deals with rectilinear motion, and this is a transitional lecture looking ahead towards what we will cover on April 9th, dealing with areas under curves. This is also something you want to be grading because I'm expecting you to report this grade. Part A, you were to find the velocity at time t equal 1. Well, the velocity curve that we have here is exactly that, is velocity versus time. And so what we can do is read that from the graph. So at time t equal 1 minute, you're going at 15 feet per minute. And so that is that's the velocity. The acceleration is the slope of that line. It's the change in the velocity over time. And so that's going to be the slope of the segment joining 0, 0, where we started, and 230. And so the rise over the run is going to be 15 feet per minute squared. So give yourself 1 point for the velocity and 1 point for the acceleration. If you got those correct, and deduct a half point if you did not
Part
get
B
the
asks,
units
when
correct.
does this particle
Let's
change
move on to
direction?
part B. Well, it's going to change direction whenever it changes from a positive velocity to a negative velocity. And so that means that it changes direction whenever it crosses the x-axis. Now by inspection you can see that it looks like it is 5. You can verify that it's at 5 if you go and calculate the slope between this point and this point in the equation of the line and see where the line hits, and it does hit at 5. But I ask at what time does it change, and so the answer to that would be it changes at 5 minutes from 10:13 or 10:18 exactly. Now it changes direction again, going from the negatives to the positive over at this point, and that is 9 2/3. And you have to think about what 9 2/3 is going to be, and we started again at 10:13, and so the answer to that one is 10:22 and 40 seconds. So give yourself 1 point for each time you got completely correct. And again, over here, what you had to do was find the equation of the line joining those 2 points and seeing where does it intersect the x-axis. Number 3, you were to try to figure out where did the particle end up at time t equal 10 minutes. And you had to realize that the area under the curve was an important factor here, because the area under the curve, under the velocity time curve, is going to be distance. And so we traveled 30 units here, 60 units here, and 15 units there. And that was all in the positive direction. That got us to 0.105. Then we moved in the negative direction from the same point, and you see we got a bunch of negative values, and then we turned around and started going positive again. So you were to calculate these areas and add them up. You're adding positive and negative numbers, and when you add the positive and negative numbers, you find that the particle is at plus 20 feet at time t equal 10 minutes. Give yourself 1 point for the correct area, the plus 20, and whenever you say it's plus 20 feet, that is the other point. Part D, we wanted to find the average acceleration and the average velocity over the entire time. So average velocity is change in distance divided by change in time. So what you did is you changed a net of 20 feet. Your final location minus your original location was 20 minus 0 divided by 10. So that is 2 feet per minute. That's your average velocity. Your average acceleration is going to be the change in that. So it's the slope of the segment joining 0, 0 and 10, 10, which was the final velocity at 10 minutes. And so when you take the slope of that line, you get 1 feet per minute squared. So for the average velocity, count 1 point. For the average acceleration, count 1 point, and deduct a half point if you did not get the units correct. Part E. You were trying to figure out there were three questions, I guess. When is the particle the furthest away from its starting point? You were also to figure out how far it is away from its starting point at that time. And you were also supposed to give a bit of an explanation. We'll say more about the explanation later. So you see that in the positive direction you went 105. In the negative direction you went, I think this is 86 2/3. And so what happens is that the furthest you were ever away was plus 105, and that was at time t equal 5 minutes. So give yourself 1 point for the time, 1 point for the distance, and a half point for, deduct a half point if you didn't get the units right, and 1 point for an explanation, talking about positives and negatives, areas under the curve, and the fact that 105 was bigger than 86 2/3. Now, if you added all these things together, what you find is that there were 11 points possible, and I want you to report your score as a percentage. So take your points earned as the numerator and divide it by 11, and then round your total to the nearest percent and report. In fact, I'm okay if you round it up to the nearest percent and report your score. And there are some key takeaways here. One is that area is going to be very important in the next class period. We're going to be studying areas. And in fact, for the balance of this course, we're going to be studying areas significantly. Areas are going to be the geometrical interpretation of the limit that's going to be known as the definite integral. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong.